managing devices from here. And right now we're on module 3 or lesson 9, and hope we can cover all of lesson 9 today. But before that, let's talk about basic stuff, right? If you ever seen one of the cases, right? This is the first thing that you would see if you do have a desktop computer, right? We'll try to go inside and check what's inside of this case or what you can put inside of your CPU case or computer case, okay? And familiarize ourselves with the components. See? So we'll go over some images and just discuss and not go over the whole text. And then I'll open up another book that shows you a different image as well, okay? So first thing that you would want as well is a power supply to basically power up your stuff. Let's see, let's go side by side. Let's move there. Okay, so power supply, without power, there's nothing to power your hardware. So this is a very important thing. And you do have to have a certain wattage depending on whatever your components are, right? So you do have to regulate that. So in terms of like if you're in a server room, you definitely would want to have basically an interface that would show what's the current wattage, like a digital numbering or digital sensor. Okay, and make sure that it maintains that wattage. And you can design failovers like this by chaining each rack, server rack to another, like what's it called, daisy chain. Yeah, well, let's see. Power. So kind of like this, you want to basically chain them so that you kind of have like a backup. So you can daisy chain different types of hardware as well. Let's see if server rack. Yeah, basically you attach one to another and so forth, and then they go to a circle. Yeah, I guess so. I stand corrected. But I just saw that in a server room before. Okay, you do have a motherboard. It's where you mostly attach your RAM stick, processor, video card, and well, you see tons of circuit there. And for the sockets, you do have different socket types. Uh, you have the USB, the display port, the VGA, HDMI. We can quickly go over those as well. As for your typical desktop external port, um, these are for your power connectors. These are for your network connections, Ethernet, modem, the older technology, PS2 port. If you remember the old mouse and keyboard ports, serial, parallel, games port, never used those before. USB definitely, SATA, hard drive, display port, VGA, this video HDMI, and all the other colored stuff before as well. Really? Still PS2. Interesting. So for me, in my experience, I did experience using DisplayPort, definitely VGA, the PS2 port, the modem, and these jack sockets. And as a kid, I used to just guess which is which. Also, RAM looks like this. It's basically a chip that you insert in your motherboard. And again, RAM provides you memory, not storage, okay? Memory. And if you have more RAM, definitely you can use more resource intensive applications. So here's how a SATA port looks like from the motherboard, and this is should be connecting to the hard drive. Graphic cards. As you can see, for me, I only know NVIDIA, AMD. Um, NVIDIA was really popular way back then as well, or when I was younger. People spend their money with video cards, expensive ones. And as you can see in this video card, it does have a VGA. Processor, this is where your CPU, you put your CPU chip in. And basically, the more cores you have, the more processes you can do. If you have single core and is it still fast, I mean, it might seem that it's doing multiple tasks, but it's only switching very fast actually. So more cores, better multitasking. And here's how you just insert your RAM. Uh, I had a chance before to just upgrade a small company's RAM, and it was pretty easy. I just Googled it, make sure the power is turned off, and you just buy one. New egg. It's basically where you can find stuff, and then after you find stuff there, just go ahead and check in other stores. Basically, if you want to look at hardware, you can look at here, New Egg. Okay, so basically you just snap this. It will basically snap in place. It looks like you need to put a bit of force there, but don't worry, it's not really gonna break right away. Graphics and sound card, as we mentioned, very important if you want to play AAA games, high quality graphics, Unreal Engine, things like those. Sound card, mainly for playing music and with high quality. Mm, I don't know what brands are there for the sound card though. Hard drive, it looks like this. There's another picture that shows the inside of it, but basically you do have a disk inside of that and a pin. And right now, hard drives are pretty cheap compared to before. You might want to check for your hard drive's speed. So the faster it is, the faster your boot will launch, faster your files will open, so faster retrievals. Hmm. Sound blaster. Hmm. SSD, solid state drive. It looks pretty sleek. It doesn't have the disk spinning disk anymore. And usually we buy these so you can have faster boot time as well. Solid state drive SSD. Uh, Optical drive. Interesting. Uh, Back in the days when we still use a lot of CD-ROM. Okay, and I think just a few months ago, I had the opportunity to a small company asked me to retrieve if there's any important disk in their uh, old CPUs, and they said they have no power anymore. But yes, there's this little hole here when you can basically put a pin so that it this would open up without needing power supply. And as they're saying here in the end, your hardware is only good as your software. Okay, so if you have a lower specs hardware and you want to run high specs software, that's not gonna work. It's gonna slow down. It's gonna log. It's gonna crash. Um, if it's the other way around, it should be fine. Unless your software requires like an older type of hardware, and that's gonna be a problem. Let's say you're gonna play legacy games and you need, let's say DirectX, I think. Yeah. So if you want to play, let's say Diablo 2, something like that, or Diablo 1, it might not run in the current um, or modern hardwares that we have right now. And if you are trying to build your own Apple, you can't really build your own Apple because they build everything themselves. You do have the option of Windows, and yes, we have Linux. Let's see, Newegg, yep, mentioned that. So the case looks like this, and make sure you manage your cable properly. Make sure the slots are uh, inserted properly, and as you can see, the port should be appearing here when you do that as well. Mounting the motherboard, you definitely want to screw them up. Installing the processor, again, you just snap it and make sure the golden pins would match the holes. And if this becomes hot, you can basically make it a frying pan. So something like this. So if let's say it is too hot, let's see if that guy is cooking. You can basically cook your eggs there. Not advisable, but a fun project. See, so you can have your eggs in the morning. Uh, I saw a video before, so steak. So that's why, yes, attach the cooler to the processor. You need to have to cool them. Again, installing the RAM, installing the PCI cards, you just basically snap them. I think in the other textbook they have better visual of the PCI as well. So PCI would include your video card if it's not built in a motherboard. I'm guessing sound card as well. Hard drive, as you can see, you do have to connect them with SATA cables. And the optical drive. I think before, I know it's a console, but I think my optical drive in my PS2 was broken in such a way it was damaging my CD games whenever it's spinning. Installing. Make sure you organize your cables properly. SATA power and data cables. The long one is definitely the power cable, and the short one is the cable motherboard and connects to motherboard and the hard disk. Molex. Front panel connectors. I forgot which is for the microphone. Is it green? Is it blue? Is it red? Just try one of those. Green headset, red mic, and that's the blue. Cable management, as you can see. You should try to make your cables organized. And installing should be easy. Let's go to the next book. I think this one. Go back here. You see the pictures. Power supply lives here. Power supply connectors, cooling fan, motherboard. You screw them. Case of motherboard, power and light wires, hard drive and DVD mount slots in here. Talked about power supplies. Motherboard looks like this. And you see the ports are exposed when you put it in the back. The PCI buses, and this is the RAM, the processor, Pci Express Slots. Here are different PCIe slots, Express slots, X1, X16, and X1. To figure them out, it's usually just listed here. As you can see, 16, 1, 1. So again, video cards goes here. And again, SATA ports in your motherboard. This is in the motherboard. And the red one is microphone, speakers, line in. Auxiliary. You can use any auxiliary, I guess. Center speaker, digital audio. I think I used this before as well. Definitely these and these ones as well. RJ45, connecting a network cable. I think the 2.1 one is display port. Yep. Sound card ports. Here's how it looked like. Your processor bottom and top. Just another RAM where you insert your RAM. You always see this like clips on the side that would make it snap when you insert it. Hard drive, again the slimmer, sleek um, SSD and the SATA hard drive. And there you go inside. You do have a platter that spins, and you do have an arm. Think of it's like your vinyl records, and you have a diamond pin to basically read stuff, and in this case, read and write. Yep, RJ45 is your blue Ethernet cables. Um, okay, CD drive, cooling fans, sound card. As you can see, the ports here for the line in, mic, speaker, and so on. Oh, Sound Blaster. Look, you guys mentioned Sound Blaster. And this one is a network card. Wireless adapters. If you have, you don't have built-in Wi-Fi capabilities, you can install as well. And definitely you can use a USB instead to get some wireless interface. Again, SATA cable. Looks like this. You screw your motherboard. Tools required. Let's see. Processor. Shorter, longer. Retention clips. This is what they're called, and notches. This is definitely one of my goals to build my own desktop as well. Let's see. Different generations of SATA cables have different transfer speed as well. Right now we have SATA E and over 16 gigabyte per second. And again, the SATA ports. Let's see. SATA power, SATA cable connection, power, BIOS utility. We can skip this to the Ubuntu part as well, which was nice that they showed an Ubuntu installation as well. So this is pretty familiar if you installed Ubuntu. Okay, we can head out of this book, and then we can go about our business with today's topic. Let's see. Where's our slides? Let me quickly download that. So basically, we're talking about hardware a while ago, and first we have to remember that we mentioned before that we have the kernel. Basically, it's responsible to talking to the hardware. Okay. And then one of the most important hardwares as well that we mentioned is this hard disk storage. Okay. You have to be familiar with different PCI buses or buses that you can use to attach different components. Opening PowerPoint. Okay. And usually what you're seeing on your screen is just basically hardware detection. Let's say you have RAM and then you did a command to check that, or maybe in your system information. It's basically doing a hardware detection. Okay. Anyway, today's topic, managing devices. And we will cover types of devices, configure devices, monitor and troubleshoot hardware issues. Importance, basically they're an interface between OS and device. Okay, so if you do have a device that you insert, if you don't have if your OS, if your computer doesn't have a driver for that, it doesn't know what to do. Remember before, sometimes when we insert a USB storage or USB mouse and keyboard, and it just shows us a question mark, and it means that it did recognize it. It did discover that device, but it doesn't know what to do with it, and that's the time you do install drivers. Crucial for devices to function in Linux, the drivers are crucial. And back in the days, it's a pain to manage your devices, but now most are very compatible. No matter device, make sure device drivers are available. Yep, and your system has those drivers. So right out of the box, your Linux operating systems would have a lot of drivers for, let's say, network devices, USB devices, and other stuff. And as they say, without the drivers, you may function poorly or not at all. So there are times that it does detect and you do have a driver, but the driver is not updated for maybe that newer version of the hardware. Would also talk about thin and thick client. Again, when we say client, think of it as just a computer, right? Like the one facing an end user. Um, so when you say thin client now, it means that you, instead of your typical setup where you have your computer and you have all your resources in your workstation, uh, basically that's not the case. That's a thin client. The thin client is you have a, let's say, a monitor, and you do have a bunch of cables that leads up to a server, right? and basically all the processing takes place on that, let's say, one server, right, and not in your workstation. Thin client is little more than a user interface. Yes, you just basically have a monitor, yeah, and interact with it. So basically, your keyboard and mouse is plugged as well. That connects to the server far away. Uh, this architecture centralizes and streamlines operations. Linux has robust remote connection support, which is good. Um, Thin client have I/O devices connected. Let's see. A server can create virtual environment for a client to work in, right? They can install those virtual environment in the server and just show that to the thin clients. Both client and server may be Linux or only one or neither. So any combination. As you can see, it looks like this, right? Uh, Everything is here. Let's say the processor, the memory, not in this one. Okay, they're basically thin or just an interface for the end user, and these are basically connected to, let's say, a server room. Okay. I think in our classrooms in CDU, I think yes, all the classroom has a thin client and basically connects to the server. USB devices, there's tons of it, and most of them would incorporate plug and play features, meaning you plug it, it just works. If not, you need to install drivers. Wow, thumb drives. Never this term. It's like an old term already. Thumb drives, USB drives, external hard disk drive. Awful, awful, awful. You buy, you try to back up, but at the same time, they break too as well. So uh, I don't know. The Passport HD brand, I think. Digital cameras, your webcams, like here. Digital cameras is when you want to read your pictures. Basically, you insert your USB to that computer and maybe store your images or videos. Smartphone and tablets. If you do wanna um, basically sync your tablets, SD cards, yes, or I think my MacBook Pro, which is a mid 2015, I still have an SD card reader, which is good. Um, the printers and scanners, keyboards and mice, microphone, webcams, and game controllers. Wireless devices as well. We do have Wi-Fi, Bluetooth, which is have a shorter uh, range compared to Wi-Fi, and NFC is shorter than the Bluetooth. Maybe just, I don't know, few inches of detection, and NFC is near field communication, and usually you can basically tap the device to a NFC reader. If you're playing Switch, Amiibo is basically NFC. You touch it to your Switch, and it reads that. Um, Bluetooth, phones have it, uh, laptops have it. I'm using Bluetooth right now to connect my headset. Video and audio devices. You have video input like webcams, surveillance cams, digital cams. Video output such as the monitor, televisions, projectors. If you have HDMI's, yep. Audio input, microphone, which I have. Some video input devices, audio output as well, headphones, speakers, USB basically are not reliable for streaming audio or video output. Um, Let's really see a USB type of connection to a monitor or to a speaker, right? Um, and you basically want to use HDMI DisplayPort because they can carry both video and audio. Older monitors like VGA, DVI, and yep, I still have one of my monitors with VGA, and they don't even carry sound. Wow, 100 meters. 100 meters Bluetooth? Wow. But I guess you would get some connection problems already with 100 meters. Printers. Linux supports printers and printing software. This is very important for, um, I guess, personal and office stuff. Where you want to print, uses multiple connection method. USB for physical connection. You can also do Wi-Fi, Ethernet adapter for network connection. Right now, most of the time, it's just Wi-Fi. Linux computer could act as print management server. In terms of printer in the exam, uh, there's not a lot of. I don't think there's any question at all about printers. If there is, it might just be basic stuff like what is cups. That's it. So yeah, network adapters. So again, you use that device to have basically a way to exchange data over network. Um, some can be added to expansions and buses. Some can be externally connected through USB. Can have more than one. Mm-hmm. And it's required for a computer to access any network. General purpose input output. They don't have designated purpose, right? It doesn't mean that it's nothing. It's just general purpose. You can use it in any way you want. So it can basically send and receive digital signals. For example, input pin can be turned on and off by external light switch. Output pin could turn on LED light. Mm. It can be controlled programmatically through software. If you played with, oh, there you go, Arduino. You can basically download an Arduino IDE and basically put some code there and then insert your Arduino with a USB to basically sync the code and make it run. A Raspberry Pi is another one. This is basically a computer, a micro computer or small computer. Can be used in IoT space. So if you ever want to dive to IoT, definitely learn Arduino Raspberry Pi. And it looks like those. And you have pins. Insert this. This is the ground. And I think these are some experiments that you can use. The first one is definitely the light bulb project. Let's see. And then you have the pin controlling the keypad, and you do have LCD as well. Let me quickly check. Let's see. And I think I was having fun before as well. You know, your first Arduino, and you can basically just hook them up. Oh, that was so fast. And you have them blinking. Maybe something like this. go blink. And as you can see, this cable is basically attached to my computer. You have the breadboard. You attach this line, and this is the ground, and this is basically your LED bulb. This one. Yeah, maybe Microsoft Teams has been having some problems, or maybe I've choose a different slower. Yeah, Raspberry Pi is easy. Let's say you want to create your own weather monitor dashboard in your home. Go Raspberry Pi. It should be easy to do. Create your own DNS sinkhole. Use Raspberry Pi. You can do that as well. SATA, we showed this bus interface for attaching standard. It's basically the plug that was shown in. Maybe I can show that again quickly. Where you plug in your hard drive, hard disk, SSDs, right, motherboard to the hard disk drive. It's basically the red one that I showed earlier. Quickly show that. So this is the cable, and this is basically the port. SCSI, traditional bus interface for connecting peripheral devices. Used for storage and peripheral. Yep. Uses a parallel interface, more costly than serial. Popular for enterprise storage. Oops. So another interface. Good to know, but I don't think it's really part of the exam. HBA hardware component that connects the host system to a storage device to facilitate input and output. It's used with basically your SATA and SCSI. Host bus adapter, and SCSI is basically your small computer system interface. PCI, it's now superseded by PCIe, so it's basically another expansion bus for attaching peripheral devices. And again, it looks like this for the PCI. PCIe. There you go. Those are the PCIe. Scuzzy. Okay, video cards, expansion cards, NME, SSD. Identifying types of Linux devices. We already showed that, the SATA, the PC, SC, SI, PCI, HBA. So to continue on, device file location, because if you're wondering where our devices are located in terms of like their representation, we do have several locations. We have the prop, sys, dev, etc. Prop is definitely files reported by the kernel. The sys creates a hierarchical view of device info. A dev is your driver files. Dev mapper is there as well. etc is for your configurations. Mhm. And we do have hot pluggable devices. These are the plug and play and are basically detected by the system when plugged in most of the time. Okay, if not, you do need to install a device driver if they are not working correctly. Code pluggable devices require a complete boot. So think of it like again in your motherboard, you just don't remove CPUs and RAM or hard disk without turning it off. Because aside from electric shocks, it just doesn't work like that. So you have to completely turn it off. The reason why is because when you boot up, remember your BIOS looks at those um, hardware in the motherboard, and after it detects, and let's say it goes to the um, looks for the bootloader using the GPR, GPT, MBR, and then when it's in the grub and initialized already, it is no longer detecting those it's not already doing discovery for hardwares that are inserted in the motherboard. Mm-hmm. Some code pluggable devices require system to be powered off. Okay. Modern distros support hot plugins for many bus type. UDEV. This is a device manager that automatically detects and configures hardware devices. Um, so this is basically the device, and when it detects, right, it will basically put them in the /dev folder. It's basically a function of system D, initialized during boot, handles configuration for both hot pluggable, the plug and play, and cold pluggable devices that you need to remove. I don't know, devices that you have to reboot the system or turn off. So as you can see, the cold pluggable modules are only loaded when system is booted, and hot pluggable modules are dynamic, and it's during runtime. Hence, this is the reason why we need to reboot or turn off, turn on. For the UDEV rules, we can basically tell them how they should configure the device command when plugged in, and you should go to etc where we put our configuration, etc udev rules.d, and basically create a symlink, for example, on the device plugin. You get unique attributes such as vendor, product ID. Let's see. And you do have a command called udev adm. It's basically udev administration. And you have a bunch of commands for like info, control, trigger, monitor, test. And it is to modify runtime behavior. And it would look like this. You can udev adm info your dev sda1, your partition. Printing softwares. Okay. Okay, we can stop here first and talk about. Let's see if we can use our box. Okay. Okay, so we go back to again. When we boot up, it looks for sound card, video card, processor, network adapters, and stuff like that. And then UDEV would basically take the hardware the kernel identified, and again, I told you it would list it in /dev. So again, the detective hardware is basically being mapped to the /dev, and again, UDEV does that. Okay. We can quickly check r/dev as well, or maybe don't do the long format. So udev is the one detecting it and mapping it to the /dev. We can see the CPU. Again, blue denotes a folder, and yellow is a hardware node. Mask in green are special permissions for execution. Uh, Light blue, they are not physical, really, not tangible, but they still get mapped. So like STD in, STD out, those blue stuff. We do have some like the dev null where we can basically um, put things that we don't want, the characters, the output that we don't want. Just like that to dev null. You have the random for RNG, random number generator, and CD-ROM, even though we don't really use it that much. TTY, you haven't mentioned this a lot before, but basically these are teletypes. Console, aka the terminal, the shell, right? We'll talk more about that later. So again, if you do want to override teletype, is basically this one. So if I say put the who command, it's saying uh, this user is using TTY1. So think of it's like console one. Because someone asked already, so let's show another one. Let's say I go to a different terminal, and let's say I log in as a different user. And as you can see, this other user is now using TTY2. So it's just terminal, right? I think it has what's the origin of this teletype again? Teletype, teleprinter, electromechanical device, used to send and receive type messages in communication channels. Uh, Teletype, yep. Mm-hmm. Yeah, old mainframe days. Who has experience in dealing with mainframes? That would be an interesting thing. Okay, so let's go back to my user, I guess. Okay, so we mentioned about the colors, some of them. Oh yeah, so now we can override the UDEV rules. It's not really that a common task that you really do to customize it, but in case you're interested, it's basically would be in slash udev and then rules. And let's see. Do I need sudo? I need sudo. And for me, I only have these. Let's see. I don't have a lot as well, actually. Let's see if I can open that up. Yep, it's pretty empty. There's nothing customized here. So it says this is sample UDEV rules file that demonstrate how to get UDEV to set the name of IP or IB interfaces to whatever you wish. Okay, to how and there's a 16 character limit on devices. Uh, IPOV is IP over InfiniBand. believe. So you can basically set action, subsystem, drivers, attribute type, address, MAC address, I think, name. Okay. So again, you don't really want to change this and mess around with it. Um, this UDEV as well can show you like the vendor ID, product ID, labels if you do have it. Um, let's see if we can just grab a screenshot. UDEV rules. I think later we might have something to show you. Oh, maybe this one. Super small. Let's see if we can enlarge that. No, this is fstab. Never mind. Yeah, but basically it shows you the vendor ID. Let's see, vendor ID. Yeah, it does not show you a lot. So again, for if you did any changes with this rule, you can basically load the rules automatically. And it will only apply the rules when it detects the hardware. So if you plug in the hardware or basically put a rule and now it detects that hardware, you can also reboot to detect the hardware again. You can force UDEV to detect. Okay, again you can remove and plug in, and then now you can use UDEV ADM to apply trigger rules. UDEV ADM, and let's just man that. It's a UDEV management tool. Yep. You can query. You can export. You can trigger. So this is when you wanna apply the rules. You basically use a trigger, so it would redetect hardware and apply new rules. So if you do wanna reapply the rules as well, there's another one is the UDEV ADM control dash dash reload rules. If you just want to reload it, right? If you want to redetect hardware and apply new rules, you do UD and trigger. I don't know what it would do for me. It does nothing actually for me. If you also just remember, if you rename a hard drive partition, it will kind of break mount points if they are targeted to device label. Because again, we can label stuff, right? The hardware. But if you're using UUID, which is a unique ID for that hardware, um, it will definitely avoid um, that mistake, like breaking the mount points. Uh, we do have another directory called the device mapper. I don't think I have only a few as well. It basically takes physical hard drive and divide it into logical volumes. Again, logical volumes are not hardware. They're not physical and tangible. As you remember, in your what you call this, in your diagram, that you do have your physical volume. So you first physically have your let's say hard disk, and you now have to do a physical volume create so that you do have some physical. Let me double check that again. and then physical volume group. Let's go with volume group first. I want to show the diagram so it's clear again. So remember, we do have our, let's say, physical 2 terabytes, right? And you basically want to do a physical PV create in your Linux so that it detects it detects it as physical volumes. Let's say you have 2 terabytes each, and once you have those detected, you can have volume group. You can VG extend to just keep extending that pool in such a way now that you can divide it in whatever way you want as logical volumes. Okay, again, volume groups, you can still create this as 3 terabytes and 3 terabytes. It's up to you. And also, we do have the FTab or file system table. And this is the usual ID. You definitely want to use this when mapping mount points. Um, if you want to see devices that are ready to be accessed, um, you definitely want to go to your sys. And these are some of the lists of your sys. And again, sys like proc is a virtual file system. Sys is basically a representation of device drivers, representation of dev. And then I guess we can quickly spend like uh, just a quick 4 minutes or 3 minutes. Have your system up and running. Go ahead and do /dev ILS dev and see that's any interesting to you. Just post it in the chat. Also mention that it's from dev and another item in your /sys and just post it in the chat and um, see what catches your fancy. So I'll give you guys like 3 minutes to do that. If you don't have it, if you don't have a lot, it's fine. Just let's see. I see. No, I meant, aren't you able to just do ls like dev, something like that? Sorry if I wasn't clear. Oh, I meant ls/dev folder. Sorry. Anyway, then we can proceed. So we do have some other commands that we can play around with. It's basically the lspci, and it would basically detect uh, hardware plug into the PCI bus. So you can see the host bridge, ISA bridge, VGA adapter, Ethernet controller. Um, what's audio controller, USB controller, SATA controller. So what basically is lspci? It is basically just calling the /sys folder, and basically gives you a more readable format. Uh, in laptops such as mine, the MacBook Pro, uh, most of the hardware is already plugged in. I mean, not the external ones. In desktop, like the RAM and CPU is pluggable. And for USB, you can do ls USB. It will show you a device there. If you don't have it, sudo yum-y install USB utils. So I already have it. So go ahead. I'll give a minute to people who wants this installed as well. The ls USB utils. Okay, so that's how you install the LS USB. Um, Basically, just to remember, if you have a graphical user interface, if you plug in a USB stuff, it will detect, right? And for example, your external hard disk, when you insert it, it will pop up an icon that says, or USB that says, here is the USB that you plugged in. Okay, I think we can quick do concept test now for the TAs. Um, let's just answer this. Different versions.
Clock. So should
Uh-huh.
we go right now?
Yeah.
Okay. Okay, the first question is up, so you can go to your chat room and select the answer you think is right. Can you guys see my screen? Okay, wait a minute.
I still don't see your screen share.
And how about right now?
You're good.
Okay. So the first question is, which location contains various files that represent system information reported by the kernel. The A is sys directory, and the B is process directory, and the C is device directory, and the D is etc. directory. So just choose the one you think is right and share your thoughts in the chat room with other students and why you think the answer is right. All right. So let me copy the answer, copy the question and the answer in the chat box. Okay. Okay, so right now we are good. So the answer is B. So we store the information in the process directory, processing directory, and so The first one is the process directory. So this one is the file that store the represent information reported by the kernel in the runtime. So the number two is the A is system. So this one is only can show you the device info. So it's not like represented by not reported by the kernel. And the diff, the answer C. So the C is the store the driver file. So it's not report any system related information by the kernel. And the etc is like store the any kind of software and configure file. So it's not also not reported system information by the kernel. Okay, so next question is up. So the second question is, which subcommand is used to stimulate a Utep event running for a device with result on output? So think about those options we just talked about in the few minutes ago, and share your thoughts to with the other student to see and to discuss with other students. Yes, did anyone want to share their answer and thought? Yeah, I would say that there's a lot of different ways to show this answer, but it's depending on how you want to do it. Okay, so we got the 20 of that. Okay, so for the second question, the answer is D, the test one. And the D is the correct answer, the test, subcommand. And so I will go first for the test. So the test is to stimulate the Utep event running for a device. So basically, the task is to you can combine with the command that show your result into the var/log in that directory. So basically, it will send the signal to the device, and if there's a like the error during the signal, or the device didn't have any response, so they will go into the debug. They will send the debug information to the log. And the other choice is the info. The answer A is info. The info is like they only show the information that running in the runtime. And the B is trigger. Trigger is like if you plug in the device but the device didn't have any response, so you can use trigger, try to figure out is the device is activated or not. And the monitor is similar, a little bit similar to the test, but the monitor is to monitor the specific events that only sent by the kernel and also update to your console. So do you have any question about these two questions or any thought you want to share? Okay, I think everyone is good. So I can get back to clock.
Okay, thank you so much, Spencer. And I believe people love the letter D, test everything for sure. Okay, back to me. So we did discuss about having the LSPCI to basically check hardware plugged into PCI bus, LS USB to see USB details. Just so you remember, when we're dealing with devices, there are scenarios that you'll need your, let's say, to do something else, right? To troubleshoot. Um, let's say you've downloaded a third party, you bought a, let's say, a third party, everything's third party anyway, a hardware basically, and that's hardware is needing a proprietary driver, right? For example, your graphics cards, your AMD, Linux won't have those. You, let's say you need to download a driver for that one. Um, it may come with in other distros, but usually they don't have the right to distribute the driver. So you just basically go to their website and download it. There might be a repository through your Yum or APT if you're using Ubuntu. Another thing is there's a scenario where you have built-in driver, but the hardware is not being detected, and we would use a command called dmessage and dmessage, and there's a lot of them. Um, no floppy controllers found. Oh, floppy disk, and it basically shows you the time in the left-hand side. You can go ahead and do dmessage less. Okay, so it shows you from the top. This is useful to see any error in hardware. You can basically see it here. Let's double check if we do have errors. Nope. Come back there. Oh, my
Mark, I
screen
think your
again.
screen is on.
Thank you for calling that out. Man. There should be a notification to say you're talking without the screen. Okay, so I just went ahead and did this actually, just the message. And again, in the first field or column, it shows you the time, sequence, and then what I did next was only do a less command. So as you can see here, you see the BIOS, hypervisor, CPU, and I was saying that you can use this to basically check any error in your, let's say, hardware that is being detected. Some of this would be data from services, which you can also see with your systemctl command. Um, Again, the left-hand side shows it in seconds. And it's sees here seconds. And initialization, SE Linux security policy, setting the PID max. PCI, PCIs. Checking the USBs. Shows you the vendor ID, product ID. System D, random, the random. Let's quickly see whether interesting here. See, nope. Okay. So as I was saying, floppy, no floppy controllers found. To check for newly pluggable devices, we basically want to do the message dash follow thing, but I don't think it would generate a lot, or the same thing as well. Man, the message. Wait for new messages. Oh, okay. So basically, when I do the message dash follow, as you can see at the bottom, it's still the cursor is still blinking. It means that if you attach the different devices, um, it will basically detect that hardware and show it here. And time is 10:45, and time for a 15-minute break. Let's see you guys in 11 a.m. PST, and we'll be back soon. And just to confirm with, I think the second concept test, um, yes, it's kind of ambiguous that all of those are device files. All of those are being reported by the kernel. So I think the answer is all. If we can be more specific on why, specifically that certain device file, right? Because like proc and sys is similar. Well, sys would just provide a hierarchical view. Mm-hmm. And etc is your configuration file for device, and device is device drivers. But if you're gonna strongly just base on the textbook, it will be the closest would be proc. Um, I would say, but not really. I'm not gonna say that 100%. Okay, let's see, where are we at? Um, so we mentioned about this D message, useful for showing errors and maybe giving it to the IT support, which is you as well. Um, and also for kernel panics, as I think Juan mentioned. So other stuff that we can check is basically the UDEV EDM. And this will basically monitor hardware changes and we'll watch the kernel. Nothing for me. So another one in my Ubuntu server. Let's go ahead and log into my Ubuntu. And let's try to do the following stuff again. Let's just see. So we talked about the deb. And have yellow colors, same, blue, std in, the random, the teletypes, the consoles, device mapper, only have control, we concatenate the fstab, again this is my AWS Ubuntu instance, AWS EC2 Ubuntu /sys. I have hypervisor, kernel, module power, kernel, bus, to bus, let's see, memory, and let's say devices, memory 1, 2, 3, 4. Nope. We can do ls PCI as well. Let's put that bigger. See if we have ls USB as well. Nope. Udev ADM. Let's try another one to basically put out a lot of information about the hardware. You can use the DMI decode. It's also useful for checking whether hardware is working or not. It gives you information about BIOS and memory. Let's see, let's do ls instead. Sorry. So you get the BIOS information, vendor SAN, Amazon, PCI supported, EDD supported, manufacturer Zen. Who's that Zen manufacturer? I'm curious with this one. Zen. Maybe this one. Nah, wrong. Memory device, and as you can see, the size 1 gigabyte. Let's double check that. sign in. Let's say I want to create an EC2 instance. Just want to see the details of the same one. It was this one. One gig. Yep. Okay, so that's for the DMID code. And for the LPR, I think we want to go back to the slides first again. So we've done this. Utep ADM. We'll just go over printing software. Printers are usually bundled with software utilities, may run on specific OS. So vendors usually provide drivers for download on their websites. Again, kind of like, let's say, your mouse or USB device. Printer software also have device drivers. Cups is basically a print management system for Linux. Okay, it can initiate print jobs from client, and jobs are processed and set to the whatever printer. It's used for scheduling jobs, processing admin commands, providing status of the printer. Has a web-based interface configuration, modifies the .confs, which is the configuration files, which is in etc. Here, how it would look like. It has a graphical user interface, a GUI. The LPR command basically submits file for printing. Think of it like doing the Control P or Apple P, like accessing this. Files are then sent to specific job printer or queue. So also, like last night, I tried doing the LPR, and it kind of looks like this. It doesn't show that. Let me remove my background. So basically printed a readme.md text. So for me, it was kind of cool as well that I know it doesn't have margins, but it does a pretty good job for printing it. Like, what do you see? Like the font that you're seeing in your terminal, it's using that as well. So this is just a readme.md that I printed. Just put it back. So again, LPR command. If I showed you my command history, exit this out, I guess. So I just did something like I didn't show here. So something like LPR, and then whatever text I want, or I can even go. So I can do LPR, and let's say random.txt, and that would print whatever's inside my random.txt, which is basically this one. We can also use LPR from an echo statement, right? So maybe you can do something like, I am coming for you, and then Pipe it to LPR. I think. Configuring devices. Don't forget the hot pluggable, cold pluggable. Looking at the /proc/dev/sys/etc. Sys gives you a hierarchical view. Dev is populated or mapped by the udev. Udev is the one that detects the hardware and maps it. And then etc is your configuration. In your experience, did you find it easy to install drivers? Put down the chat below. I'll give a quick 1 minute. Share your experiences in configuring devices. The easy, the hard, the good, the bad, and maybe what distro has easier way to configure devices or not. Same here, Alex. I installed drivers as well. Update driver. During those days, sometimes it does not work as well. Okay. Yeah, that's good. Activity optional. Using UDEV to manage a hot pluggable device. They even said optional. A colleague preps installation media on a USB drive. System assigns non-descriptive name to drive. She wants to reference the drive using a more helpful name. Maybe change the name and use just the UUID. You'll use UDEV to create symbolic link to the drive. Will activate every time the drive is plugged in. Will be based on device's unique attributes. UUID. That's a spirit. Configuring a virtual PDF printer. HR wants to distribute AUP to employees, both hard copy and electronic. So the clue here is hard copy and electronic. Use a redirection or a pipe. You can maybe do a T. So, or you can do it basically save it to a file first and then print it. You can have a script like that. Or again, you can just use something like it both outputs to, it both goes to the printer and saves to a file. LSDev, display information about system hardware, compiles info from proc, interrupts IO ports, proc DMA, and as we mentioned, we did have Ubuntu here. Let's try that. If we can do LSDev here. Not found. Sudo install proc info. Thank you for that prompt. Now we got that. Let me just double check. Also, you do have prox interrupts, prox IO ports, prox DMA that was compiled from and showed you like the interrupts here, ports, the DMA. Is there a better way to represent this though? Options, none. Huh, interesting. Oh well, moving on. LS USB displays info about devices connected to USB. We did that. It's basically just scans the dev bus USB directory. LS USB, there's none for here. LS USB, and they did say it's the same as the dev bus USB directory. So mm, that's a hardware module. Don't know if we can even check that. Nope. Nope, it's not gonna work. Yep. But basically that's it, the 0001. This is the 0001. Print V to more details. Let's try that. LS USB B. Looks more readable, I guess. Now you see the ID vendor, the ID product. Can filter by bus or by vendor. Okay. Can skip that. So here we go. Same one. It shows you the bus number, the device ID here, and the vendor products. Ooh, Qualcomm, Bluetooth, Linux Foundation 3.0, and this one is a 2.0. I think that's a USB hub. LSPCI, we showed this already. List of connected device connected to the PCI bus. Oh, includes verbose option. Let's see. I think we didn't try that verbose option. It's great. So don't forget that. I know this is not follow along, but go ahead and just try this out. LSPCI, always try out different options of a command, because that kind of gives you the muscle memory. Shows the slot, the class, the vendor, and product. What's that? VV. Interesting. So what Juan has given us is VVV XXXX. He said that it's good. good to know. Don't worry, they're not gonna ask like complex combinations of options. LPQ shows a printer queue. Reports for each job, the job rank, who owns the job, and the name of the job is the file, the size of the job. Plus interval to update report every specified number of seconds, and we'll use the full printer if non-specified. Let's try that in my Mac, if we can access that LPQ. Ooh, so yep, it did detect my printer here. Pretty cool. I think I would now start printing in my terminal. How about interval? Oops. LPQ. Oh, I need seconds. Why is it listing those files? Interesting. So that's LPQ. Additional device monitoring. We did already use the D message. It just shows you device driver message sent to the kernel and can include errors. Again, for errors, monitors issues related to drivers. You do have LSBLK to identify block storage devices. Let's check it in my Ubuntu first. LSBLK. Yep, it shows you those. Let's see in my CentOS, LSBLK. Basically shows you your SDAs, your partitions, your mount point, and let's see if I do have that in here in my Mac. LSBLK. Nope. I have to install that, I guess. Never mind. So it identify block storage devices. Again, block ls block. Ensure devices are recognized and correctly partitioned and mounted. Monitoring devices. We can just skip this. Maintain a list of hardware resources in use. So maintain. If it says maintain, maybe don't forget to um, use the output from your ls whatever for the hardware and just dump it to, let's say, a text file. And maybe you can run a scheduled job for, maybe a scenario is every time there's a new hardware, or maybe you can just schedule it during a period. Every 15 days, uh, give me a list of hardware and basically use the diff command to see the changes between the previous one and the newly created list that you dump in a text file, so maybe you can keep track of hardware changes over time. Common hardware issues. Yep, we have gone through this. Missing and poorly configured drivers. Downloading the drivers from the proprietary, to whoever the vendor is, the third party is. Incompatible user space software, compatibility issues. Many potential solutions, rebooting, redetecting the hardware, again, downloading the driver. Issues category, keyboard mapping, communication ports. Yeah, keyboard mapping. Sometimes this is a pain when you keyboard. and you're using Mac, and sometimes it does not map properly in terms of like when, let's say, I input letter L, it goes to like letter or whatever gibberish character it does. It's not even like a different locale. So you have printer, memory, video, storage, adapter. So printer, you have the cups. It has GUI. You can do admin stuff. Memory, you do have your can do LSPCI, the procs, the sys, video the same, storage the same. Keyboard mapping issues. So, oops. Just don't forget, it may be because you changed the wrong keyboard layout. Like for example, if I accidentally do something like, what was my command? Let's say this is changed to this one, and it's like don't know what's happening. Why is it doing like that? And why is it putting characters? Right? It's like so you can basically um, just need to adjust your language layout. Start identifying the layout of the actual keyboard. Locale status. This is a recap. Let's see if we can use it in our oops Ubuntu. Mm-hmm. Let's see if that. Oh, let's see if this. I have it here first. I don't have it, so I can't even check it. Okay, just going back. So it's just system language, communication port issues, um, ensure device is loaded into port. It might not be, you might not have snapped it properly. Cables are undamaged or not loose. Again, cables have this wear and tear. So if you try to maybe um, maybe bend them in such a way that you always bend them all the time, uh, you might end up um, destroying one of the fibers or cables in the lines inside. Typically, true for most audio jack, like a 3.5 millimeter, uh, which is kind of mm, like this. This is very flimsy cable. It's not showing again. Never mind. But you know, the auxiliary cable you put in your car as well, or speakers. Uh, okay, don't forget install load necessary drivers. Okay, printer issues. We went through those. Memory issues is exhausted. Performance degrades. Physical RAM. Common issues. Blank screen, wrong color, multiple monitors not detected. Um, ensure your HDMI DisplayPort VGA is properly connected. Check if you have the driver. Storage adapter issues. Very slow write compared to your baseline. Device is not detected. Reduce capacity. It might be there's a virus or a bug that's causing it as well, dumping a lot of .trash or .ds underscore files. Move on. LSHW list each detected hardware components and details. So with this one, we can pull out details for multiple device locations. Outputs again, it's almost the same. Outputs motherboard, CPU, RAM, peripheral. We can go ahead and check that. LSHW. Let's put a less. So it shows you motherboard, 1 GB, Intel Core i7, the host bridge, DVD reader, multimedia audio, and let's see, LSHW, less, Intel, host bridge, Intel. I have it, oh, not in my Mac, it's fine. Device class, oh that's good, you can basically use that option. Maybe not here. What's that option again? Input, PNP device. Should run this as admin, so let's try that. Same. DMID code, if you want to dump info in a human readable format, and ABRT, utility that analyzes reports, automatic bug reporting tool, just the guidelines. You just read this on your own, and activities. So let's quickly do a follow along. Just a quick. This is just a quick activity. So open up your VirtualBox. We went through this already. Let's just do a quick teletype exercise. I'll give everyone 1 minute first to have their VirtualBox up and running. And just quickly put the who. And hopefully teach you how to access a teletype. There's another way. PNP plug and play. Yeah, thanks for that. Okay, you should have your CentOS up and running now. So type who, and let's say I wanna use the login prompt of teletype number 3. I basically should do, I'll just paste it, Control plus Alt plus F3. Control Alt F3. It shows me another login. I can log in again as my own, but let's say I want to be root this time, right? And I can basically access who again to see now root is using the teletype 3. And then if I want to move back to the first one, I can just basically do Control Alt F1, F2, F3, or Alt then the arrow again, left and right. So I can basically, let's say, do Control Alt then F5, and let's say I'll just use the same user and do a who. And as you can see, I skipped 4. Okay, I basically jumped to 5 because I did Control Alt plus F5. Maybe try another one for the last one before we move on. Control Alt F8. F8. Did not let me actually, so F6 should be, I think, F6 instead. Yeah, F8 doesn't work, sorry. F6 instead. And now, for this exercise, what we want to do is maybe just be as a root user. And let's recap what we learned before. We can do top. Let's see. You can share your username. And just basically kill that. Okay, so what I did was top command, enter, and press U to filter by user. And enter, so it filters. Press K, and I'm just gonna plug in the IDs and put 9 as a kill command, and repeat it again. Kill everything. Oops. Sorry. Kill 2600 and another 9. A sig kill command. Let's do another kill. And don't forget we want to delete everything, so do another username. Let's go with jcho. And let's kill that as well. Press K. 1591. And 9. So Jesse, in terms of the meeting, um, don't forget to clarify that with Amaris, because I do know that there are times that they're meeting you as a group and maybe individually as well. But I believe that this might be a group meeting because it's a Wednesday. Yeah, so please go ahead and answer Jesse's question so that you don't miss out the meeting with Amaris. Well, it looks like a group. Yeah, it looks like a group then. Okay, cool. So because you guys have 12 to 12:30, uh, let me just wrap up in 2 minutes so you guys have an extra break before your meeting. So at least you have a longer break somehow. So let's see. Let's see some of the important stuff here. backups. You just read through it. Unfortunately, the activities here, some of them, it's like something that you can't really do as much, especially like the printer stuff, unless you're able to hook it to your printer. Let's just quickly see the activity section if there's anything important. So you want to check the printer queue. We already mentioned that this answer should be LPQ, then dash capital P, and then this one HPLJ5. So that's going to be LPQ dash P HPLJ5. And LPQA, this one will basically display all configured printers. This one, all the USB buses and attached devices, USB attached devices. Pretty straightforward. Which command can you see information about all block devices? The clue: ls block, ls blk. lsdev command pulls its information is from the procs interrupts, procs IO ports, and procs DMA. It shows in the slide. It also showed in the guide above. You check this more. And it's 11:45. I'll give you guys more break. And don't forget your 12 p.m. meeting with Amaris. And don't forget to be back at 1 p.m. PST. So you guys have 12 p.m. meeting with Amaris. Go take your break. And then be back 1. Okay, thank you very much. Have a short, wonderful break, and we'll see you in the afternoon. Bye.